Well, in this exercise, a tennis ball is thrown vertically upward with an initial velocity of 8 meters per second. So they are giving me the first information about the object. The object is a ball, okay? The object is a ball, and wait, I cannot find the pencil. Ah, so we have a tennis ball, okay? And I have this tennis ball, and it says, the exercise says, it is thrown vertically upward. So the motion that this object originally has is going upward, okay? This is the first motion that this object has. And I know that its initial velocity is 8 meters per second and is positive. Why? Because it is mentioned here in the problem. It's positive for two reasons. First, because the symbol is there, that makes it positive. And second, because it says vertically upward. And upward is going to be indicated with a positive sign. Okay? So that's what happens in this exercise. In the part A, it says, what will the ball speed be when it returns to its starting point? So in other words, this ball is going to have this motion. It's going to move upward until it no longer continue moving upward, and then it begins to move downward. Okay, like every object. Imagine that you throw an object. This is the motion that it has. Okay, it goes up, okay, until it's no longer possible, and then it continue moving down. So this is what happened here. In the first question says, what is the ball speed when it returns to its starting point? So the ball was initially here. This is the original position. Okay? That is the original position. But what happened? It was moving upward, but then where does the ball end? As the question said, it ends, or it returns to its starting point. So that means that the ball is going to end over here in the same original position. So the initial and the final position are going to be the same. Another way to say it is that the initial vertical position of the ball is equal to the final vertical position of the ball. Therefore, delta y, how do you get it? By subtracting final minus initial. And you might be thinking, Miss, but I don't know what is the position because it's not mentioned in the problem. It doesn't really matter, okay? Think of a number. Tell me whatever position you want. Tell me a number for this position. What position is this one?
4.
Well, 4, okay? So, the condition is that delta y is equal to the position 4, okay? So, if final position is equal to the initial position, then it's 4. So this is going to be 4 minus 4. In the end, this is going to give you 0. Why? Because as the question says, the object returns to its starting point. El objeto regresa a su punto inicial. So there was no change in the position. Yes, the object moved, but in the end, the object ended up in the same position that it was initially. Okay? So this delta y equals 0. In other words, it means that there is no change in the vertical position. Because it ended up in the same position that it was initially. Here it doesn't really matter, okay? I said give me a random number because the problem doesn't give you the position. The problem is giving you the velocity, okay? Which is different, but it's not giving you the position. But it doesn't really matter because the problem tells you that the ball returns to its starting point. That is a way to tell you, that is the way that the problem tells you that there is no change in the vertical position. In other words, delta y is equal to 0. So what happens if delta y is 0? If delta y is 0, and you have to calculate the final velocity, so final velocity is equal to the square root of initial velocity to the second power plus 2 times gravity delta y. What do we know about delta y? We know that delta y is 0. And if it's delta y is 0, that means that all this second term is going to be 0. Okay? So in other words, the final velocity is going to be equal to the square root of the initial velocity to the second power. Okay? So you can see that it's even simpler than you were expecting. Now, one thing about this is the direction that the ball is having. When the ball is going upward, it has a velocity of 8 meters per second positive. But what happens when the ball is coming downward? How is this velocity going to be?
Negative.
Exactly. The final velocity here is going to be negative because now it's coming downward. That you need to be very careful on that. So remember that in here, the final velocity is going to give you a negative sign. And in the part B, it's asking you about the time. It says, how long will the ball take to reach to its starting point? So you need to find the time. In what formula we have to take the time? Final minus initial velocities divided by gravity. In this final velocity, remember that is negative. Don't forget to write the sign. If you don't write the negative sign, it's going to give you 0, and that is impossible. It's impossible the time to be 0, okay? So you need to be careful on that. Knowing this, you should be able to make the exercise number 4 without a problem. Now, I told you yesterday that this was the last time that we saw the topic about free fall. Kelly, are you there? Christian, Roberto, Christy, turn the cameras on, please. Kelly, are you there? Kelly, are you there? Goodbye, Kelly. Stacy? Annie? Okay. Okay, so as I told you, today we're going to start a new topic that is called, well, it's the introduction to motion in two dimensions, okay? And so far, I just want you to know, so far, we have been learning about objects that are moving. Objects that are moving horizontally, like, for example, a person walking, that person is moving horizontally. Unless you're a Spider-Man, your motion is going to be horizontal. When you drop an object, in the other hand, like in free fall, the object is going to have a vertical motion only, because it's just going to be moving vertically. Now, that is motion in one dimension, because either the object walks horizontally or the object falls. In other words, just one dimension. Now, today I'm going to introduce the topic about motion in two dimensions. And to do that, we're going to need our friend, the Pythagorean Theorem. So this is also known as Introduction to Vectors, okay? Or Introduction to Motion in Two Dimensions. The Pythagorean Theorem is a theorem that was proposed by him, okay? And what happens here? Yes, I'm going to send you the presentation after the class is over so you can write this presentation in your notebook. Remember to specify that this comes from the virtual class, okay? Week 1, virtual. And you write the date, don't forget. So we have over there a triangle, or what we know as a right triangle. How do I know it's a right triangle? Take a look to the definition of a right triangle. The right triangle is a triangle that has a right side, therefore a 90 degrees angle. How do you recognize that you have 90 degrees? This tiny square that is located in a corner, okay, that indicates that you have an angle of 90 degrees. If you take your protractor and you measure this angle over there, it's going to give you 90 degrees, okay? It's going to give you 90 degrees. So what happens? A right triangle is a triangle that has an angle of 90 degrees. That is the definition of a right triangle. And I wanted that you guys notice this. You recognize the right angle because you have the tiny box in the corner. Okay? Now, a right triangle is going to have two legs, and a hypotenuse. The legs are going to be denoted by the letters A and B, okay? And the hypotenuse is going to be denoted by the letter C. Now, the most important thing is how or where do you identify the hypotenuse? The hypotenuse is going to be located in front of the right angle. Take a look over here. The hypotenuse is located in front of our right angle. So the right angle is over there. Okay, what is going to be the hypotenuse? The side that is in front of the right angle. So the hypotenuse, in other words, is going to be the longest side. If you measure the three sides, you will notice that the side C, the hypotenuse, is going to be the longest of all of them. What is the Pythagorean theorem? The Pythagorean theorem is this one over here. A squared plus b squared equals c squared. Then we have an example. There we have an example. We have a right triangle. I know that it's a right triangle because I recognize the angle of 90 degrees. Okay? And then I see they're giving me a leg A to be equal to 3, the leg B that is equal to 4, and they're asking me to find the hypotenuse. So, take a look over here. The side or the leg A is 3. It measures 3 units. The letter B, the leg B, it is 4 units. 1, 2, 3, and 4. So by definition, if we apply the Pythagorean theorem, we're going to notice that C is going to be the addition of A squared plus B squared. And what is the square of a number? The square of a number is actually a square. For example, 3. For example, 3. 3 squared is going to be equal to 9. Or 3 times 3. In other words, the square of a number is a square. Take a look over here in A. 3 squared is equal to 3 times 3, okay, which is 9. So this in the end is gonna give you a box, a square, that measures 3 times 3, okay? And what is 3 times 3? Is 9. So if you add all the tiny boxes that are making up that square, it's gonna give you a total of 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. You can apply the same concept for B, okay? How much is B squared? B squared is
16.
4 squared, which is 16. And by definition, you're gonna have 16 units inside that square. Okay, so you're gonna have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay, so here what happens? You can see the perfect right triangle over there. How much is going to be C? To calculate C, or to calculate the hypotenuse, you need to get a square root in both sides of the theorem's equation. Remember what we do in physics, okay? When we need to get rid of the square in the equation of final velocity square, what do? We get a square root in both sides of the equation. So we're going to do the same here. We're going to apply the same principle here. So you apply the square root in the two sides of the equation. In this way, you get rid of the square, leaving you the hypotenuse alone. So hypotenuse, therefore, is going to be equal to the square root of A squared plus B squared. The leg A, which is 3, raised to the second power, plus B, that is 4, raised to the second power, is going to give you 9 plus 16. In other words, 9 plus 16, which is 25. The square root of 25, that is 5. In other words, the hypotenuse in a right triangle, which have a leg of 3 and a leg of 4, is going to give you 5. Now, to demonstrate this Pythagorean theorem, I'm going to share the screen. So you can see this demonstration, okay? In this way, you will notice that what you see in numbers, what you see in a formula, is demonstrated in real life. So, here in this video, you notice that we have a right triangle. How do you recognize a right triangle? Because there, in a corner, you can see the symbol of a right angle. So you see that you have a right angle. So with this video, you are able to see that the two squares that are making up the two sides of the right angle is going to give you exactly the hypotenuse. Okay, exactly the hypotenuse. This is the hypotenuse because it is in front of the right angle. Okay, so all the liquid that was here and also here now is making up all this liquid in the larger box. In other words, with this video, you are able to notice, you are able to see the demonstration of the Pythagorean theorem. I noticed that some people left the video. I'm going to check the attendance one more time. Okay. Roberto Steven Wilmer. Okay. Bueno, sorry, I was checking. I go back to the presentation. We can also use a Cartesian plane. In a Cartesian plane, as a reminder, we're going to have two axes. A horizontal axis that is going to be denoted by the letter X. So remember, horizontal, X, vertical, Y. Okay? So whenever we talk about a vertical component of a vector or a vertical leg of a triangle, we're going to be talking about a component in Y. Whenever we talk about a component that is horizontal or a horizontal leg, we're going to be talking about an X component of the triangle or an X component of the hypotenuse. So the right side of X is going to be positive, the left side of X is going to be negative, upward in Y is going to be positive, and downward in Y is going to be negative. Remember to use the Cartesian plane to know about the signs of a vector. Now, with this exercise from here, I'm going to ask you to participate. Okay? The corners are A, B, and C, okay? And the sides are 1, 2, and 3. So with this exercise, I'm going to ask you to tell me, to identify the legs A and B. What leg is going to be A?
1.
Very good. What leg is going to be B?
3.
Where is the right angle?
We don't have. Or is in the corner here?
It's in the corner. What corner is that?
B corner.
In the B?
B corner. That is correct. So where is going to be the hypotenuse?
2.
Exactly. The hypotenuse is going to be 2. Why? Because it's in front of the right angle that is in B. Even if you don't see it like a box, okay? Sometimes you're not gonna see it. Very good. Your participation was perfect. So take a look. So 1 is the leg, 3 is the other leg, the right angle is at B, and the hypotenuse was in the position 2. Very good. Now let's see in this one. I'm gonna do the same, okay? So this is going to be my corner A, my corner B, my corner C, and my sides are going to be 1, 2, and 3. Which is the right angle?
Corner B.
Corner B. Where is my hypotenuse?
1.
Where is my leg A?
1.
No, 1 is in front of the
3.
angle.
Okay, 2.
Okay. I wanted you to see that. The legs doesn't matter. Legs can either be A or B. It doesn't really matter, okay? That's why here in the presentation you see that I don't specify the leg. I just write leg and leg. Okay? I don't say that this is leg A or leg B. It doesn't really matter. What matters is that you identify what leg is horizontal and what leg is vertical. The right angle is located in the position B and the hypotenuse in the position 2. Tell me, the leg that is in the position 3. This is the position 3 and this is the position 2. Okay? The leg that is in the position 3, is it vertical or horizontal?
Vertical.
Okay, so this is going to be my y component. The leg 2 is horizontal or vertical?
Horizontal.
It is horizontal, so this is going to be my x component. And my hypotenuse, that is located in the position 1, is going to be always in front of the right angle. That's what I want you to understand. That's what I want you to identify. What is horizontal and what is vertical. Because those, my friends, are making up what we know as the vector. The vector itself is going to be like the hypotenuse. So you need to know that that vector is going to have components in x and y. That's why it is important that you identify horizontal